Welcome back everyone. In this video we're going to discuss about coordinate geometry. Here we're going to learn about graphs. So without any further ado, let's get started. Let's say we have a plane here, okay, and randomly we draw a point here. Now the question is, how will you describe the position of this point? Some of you may say it's on the top, it's on the right side, so top right, okay, but top right means anywhere here, anywhere in this vicinity. So we do not know where the position or the exact position of this point is. Now to solve this, mathematicians came up with coordinate geometry. Okay, they said, let us divide this plane into four quadrants using two lines, okay, two perpendicular lines. Now these lines, they gave the name y-axis and x-axis. So x-axis and y-axis will divide this whole plane into four quadrants or four parts. This will be called your first quadrant, this will be called your second quadrant, this third quadrant, and this to be your fourth quadrant. That is, we go anti-clockwise. By doing this, we know that this point is in the first quadrant, but it is still not exact, right? The point may be here, anywhere. So what we do is, wherever these two axes meet, we mark it as 0, and we take equal sizes and we mark it as 1, 2, 3, 4, 5 along x-axis, and 1, 2, 3, 4, 5 along y-axis, and below 0 it will be negative. So minus 1, minus 2, minus 3, minus 4, and minus 5, and here it will be negative again. So minus 1, minus 2, minus 3, and minus 4. So remember, on the right hand side of the x-axis it will be positive, on the left hand side of the x-axis it will be negative. Okay, on the top of y-axis it will be positive, and at the bottom it will be negative. Now let us try to exactly pinpoint this point. Okay, so first of all we move along the x-axis. So if you move along the x-axis, you can see that you'll have to move 1, 2, 3, 4 steps. So 4 comma, now along y-axis if you move, you have to move 1, 2, 3, 4. Okay, so 4 comma 4. Now the coordinate of this point will be 4 comma 4. That means along x-axis 4 and along y-axis also 4. It is to be noted that we first move along x-axis and then only y-axis. We cannot move along y-axis first and then x-axis. Okay, so let us take another point. Let's take this point. So if you look at this point, we always start from the origin. So if you go along the x-axis, it is minus 2. So minus 2 comma, and along y-axis it is 2. So minus 2 comma 2. Let us take one more point. Let's say this point. Okay, so first of all move along the x-axis. So this point, as you can see, it is 3. So 1, 2, 3, and along y-axis will be minus 1, minus 2, minus 3, minus 4. So this point will be 3 comma minus 4. That is, this is the x-axis and this is the y-axis. Let's take another point, that is here. So first x-axis, so minus 3, and then y-axis minus 3. So this point will be minus 3 comma minus 3. Okay, now let us draw this point, that is 2 comma 5. Now we know that 2 comma 5 means first x2 and then y5. So x2, so 1, 2. Okay, now I know where I am on the x-axis. I don't know where should I go for the y-axis. So let's look at the y coordinate, that is 5. So positive 5 means we have to go up. So 1, 2, 3, 4, 5. It'll be here. So this will be my point 2 comma 5. And let us see this 5 comma 2. So again along the x-axis. So 1, 2, 3, 4, 5 comma 2. So positive. So 1, 2. Okay, so it is obvious that this point is not same as this point, right? So we say that 2 comma 5 is not equal to 5 comma 2. That is, even if you interchange their position, the points don't become same. Okay, they actually are two different points. Now in general we can say that a comma b is not equal to b comma a. Okay, but only if a and b are not same. If a and b is equal, then we can say that, let's say this 2 comma 2 is equal to 2 comma 2, because let's say this 2 comma 2 means this point, first x and then y, and then 2 comma 2, so same point, right? So obviously if a and b, that is x and y coordinate, are same, then it doesn't really matter which one you write first, it'll be same. Okay, but always remember x first and y second. Okay, y cannot be first and x cannot be second. This is a standard: x first, y second. So we have already discussed the conventions of sign. So for x-axis, right of O or right of 0 is positive, left of 0 is negative. For the y-axis, above 0 positive, below 0 negative. Okay, now that we have understood this, let us understand the meaning of this. In quadrant 1, you see, in quadrant 1 x will be this side, so that means x will definitely be positive. And if you have to stay in the quadrant 1, that means you'll have to move up, you can't move down, right? So if you move up, again it is positive, so x is also positive, y is also positive. Whereas in the second quadrant, for let's say this point, you have to move towards this side for x-axis, that means x will definitely be negative, and again you have to move up, so y will also be positive. For the third quadrant, let's say this point, you have to move this way along x-axis, that means negative, and along y-axis downwards, so negative. Okay, for the fourth quadrant, x you'll have to move this way, so it will become positive, y you'll have to move downwards, so it will become negative. Okay, so for the first quadrant, positive, positive, second quadrant, negative, positive, third quadrant, negative, negative, fourth quadrant, positive, negative. So basically if you just look at any point, okay, you don't have to know what the number is. If you know that this is positive and this is also positive, we can definitely say that it is in the first quadrant. If it is negative and positive, second quadrant, negative, negative, third quadrant, and positive, negative, fourth quadrant. Now let us now discuss mirror image. Okay, what does mirror image means? Let's say you are standing here, this is your mirror, so obviously you will see your image here. Okay, now what are the properties of this image? The property is that the height of this image is equal to the height of yours. Okay, so both of your height is same, and also the distance between you and the mirror and the distance between the image and the mirror is also same. So using these two properties, let us understand how the mirror image for these points are created. Let's see this point. Okay, this point is P. We know the coordinate of P is first x-axis, so -2, then y-axis, so 1. Okay, the coordinate of this point is -2, 1. So what will be the mirror image along y-axis? Means here we're considering this to be the mirror. Now you know, if a person is standing here and if this is the mirror, his image will be here, and we know that distance between this and distance between this has to be same. So from here to here the distance is 1, 2, so here also 1, 2. So this is the image of P. Now if this is your mirror, then you know that this will be the image. So distance between mirror and the object is 1, right? So between image and the object, also image and the mirror also 1. Fine. Okay, let us understand this with the help of another example. Let's take this point. Now this point, if this is your mirror, then it is 1, 2, 3, 4 units away, right? So this side also the image has to be 4 units away, so yeah, 4 units away. Okay, similarly along the y-axis, it is, if this is your mirror, then it is 1, 2, 3 units away. Then along this also it should be 1, 2, 3 units. Okay, so if you pinpoint, it is 3 units away from here. Now that we know how to find a reflection of any point, let us see some standards. Okay, so if x is also positive, y is also positive, along x-axis x will remain positive but y will become negative. Alright, that is, x will remain same and y sign will change. Remember, the values won't change, just the sign will change. Okay, positive became negative. Similarly, along y-axis x sign will change and y sign will remain same. Similarly for all of them. Okay, x along x-axis remains same and y along y-axis, that is, if the reflection is happening along y-axis, then y remains same. Okay, so we can say that x will remain same. Okay, that is, if the reflection is happening on the x-axis, then x will remain same, and if the reflection is happening along y-axis, then y will remain same. Okay, so let us take one random point to understand this. So let's say 2 comma minus 7. Okay, now without drawing it in the graph, let us use this rule to see if we can find out the reflection for this or not. So let's say along x-axis. So along x-axis we know that x will remain constant, so we can just write 2, and y will definitely change, so it will become 7. So the coordinate of the image along x-axis will be 2 comma 7, and if the reflection is happening along y-axis, then we know that x will change and y will remain constant, so it will be minus 7 and 2 will become minus 2. Okay, you can try it here. Let us do one more. Let's take minus 3 comma minus 7. Okay, minus 3 comma minus 5. So minus 3 comma minus 5, along x-axis we know that x won't change, so it will be in minus 3, and 5 will change, so it will become 5. And along y-axis x will not change, sorry, y will not change, x will change, so it will become minus 5, and x will change, so it will become 3. Let us look at this here. So minus 3 comma minus 5, so minus 3 first along x-axis, then minus 5 along y-axis. So this will be my point. So reflection along x-axis means this. Okay, so I have 5 here. So minus 3 comma 5, let's check if that is the point. So minus 3 comma 5 means again minus 3 comma 5. So yeah, the distance between this and distance between this is same, so this is definitely correct. Along y-axis means here, so it will be this distance, right? This distance is 3, so 1 2 3 should be here. That is what, 3 comma minus 5, so 3 comma minus 5, it is correct. Let us now dive into some numericals. So the question is, in which quadrants do the following points lie? Okay, so in which quadrant does this lie? We know that this is positive, this is positive. When both are positive, it's definitely the first quadrant, right? Let's look at the second one. This one's negative, means you'll have to move along this, and this positive, so you'll have to move along here. So we know that this is second quadrant. For this one, both are negative, that means first here and then here, so this is definitely third quadrant. And this is 5 comma minus 3. 5 comma minus 3 means first along x-axis or towards the right and then down, so this is definitely fourth quadrant. Okay, let us discuss this question. On which axis do the following points lie? Okay, 5 comma 0. Now we know that this is my x value, this is my y value, so let us take the help of this graph. So 5 0 means 1 2 3 4 5 along x-axis and 0 along y-axis, that means you don't have to move at all. So this is my point, so we can say that this point is on the x-axis. Second one is 0 comma minus 7, that means first one, that is x is 0, that means I don't have to go anywhere. Next is minus 7, minus 7 means y-axis, so 1 2 3 4 5 6 7 minus 7 here, that means this is my point, so the point is on y-axis. Third one is 0 comma 5, so again x is 0, so I don't have to move. 5 means 1 2 3 4 5, that is here, so that means it is on the y-axis. And minus 7 comma 0 means 1 2 3 4 5 6 7 minus 7, and 0 means I don't have to move along the y-axis, so this is my point. So this is definitely y-axis. Okay, but you will not have a graph to do it every time. So how do we understand this? If the y-axis is 0, okay, if y-axis is 0, then it is on the x-axis. Okay, and if the x coordinate is 0, then it is on the y-axis. Very simple. Y0 x-axis, x0 y-axis. So here y is 0, so definitely x-axis. Here x is 0, so definitely y-axis. Here x is 0, so y-axis. Here y is 0, so definitely x-axis. Sorry. Let us see one more question. Plot the following points on the graph paper. Okay, so first of all you draw the graph, that is x-axis, y-axis, and then you divide it into intervals. Okay, now let's see. 3, 5. Now we know that this is x, this is y, standard, right? So let's move 3, positive 3, so we'll move this way, and then 5, so 1, 2, 3, 4, 5. So this is my point. Okay, let's do the second one. -2, 4. So -2 means -2, and 4, so positive, so up 1, 2, 3, 4 here. -6, -3. This is x, this is y. So -6 means -1, -2, -3, -4, -5, -6. So here, and -3 means down, so this is my point. 5, -3. So again, this is x, this is y, so 5 means 1, 2, 3, 4, 5 on the positive side, and -3 means down, so this is my point. It is as simple as that. Let us see one more question. Now this question is reverse of the previous question. Let us understand how. So here you'll have to write down the coordinates of the points. Okay, so there the points were given and you had to plot where they are, right? The coordinates were given and you had to plot where the points are, and here the points are given on the graph. You'll have to write down their coordinates, so just the reverse. Okay, so let's look at the first point, P. Now to find out the coordinate, first of all draw perpendicular on both the axes. Okay, that is a straight line here and a straight line here. So you see that on the x-axis it is 3, on the y-axis it is 4. So the point or the coordinate of P will be 3, 4. Okay, let's see one more, Q. Q is here. So first step, draw lines on both the axes. Take the x-axis first, so -3, y-axis is also 3. So -3, 3. Let us take one more, R. So this is R. Again, draw perpendicular on x-axis and y-axis. Along x-axis it is -4, and along y-axis it is 5, so the point becomes -4, 5. Let us take one more, S. So again, draw perpendicular. Along x-axis it is 4, along y-axis it is -3. So as simple as that. Let us do one question shown on the left hand side of your screen. So it is given that ABC is an equilateral triangle. Coordinates of B and C is given. You have to find the coordinate of A. Now we know that A is lying on the y-axis. That means its x coordinate will be 0. So it will definitely be 0, something. Okay. Now how do you find this something? Basically you have to find how far this is from here. That will give us the y coordinate. Okay. So how do we do the sum? Let's see. So here BC is equal to 2 plus 2, which is 4 units, right? So BC is equal to this plus this. So from here this distance is 2, because till here it is 1, 2, and here again 1, 2. So this is 2, this is 2. Now 2 plus 2 means 4. So BC is equal to 4 units. Since triangle ABC is equilateral, we know that AB will be equal to BC, will be equal to AC, will be equal to 4 units, because all three sides are equal and they will be equal to 4 units. So that means AC will also be equal to 4 units. Now if you apply Pythagoras theorem in this triangle, this becomes your hypotenuse, this becomes your other two sides, right? So by Pythagoras theorem, hypotenuse square is equal to sum of the squares of other two sides. So AC or CA is 4, so 4 square. OA is what we have to find, so OA square, plus OC is nothing but 2, so 2 square. So 4 square is 16, 2 square is 4, it will come here, it will become this. Okay, then this is 12, so OA square, so OA will become square root of 12, which is nothing but 2 root 3. So that means this distance is 2 root 3, so which will be the y coordinate, it will be equal to 2 root 3. So hence A is equal to 0, 2 root 3. With this, we conclude the coordinate geometry. I hope you have understood everything, as it is very simple. So, thank you everyone for watching. I hope to see you in my next video. Take care everyone.